Are live. Okay, so here's what we have. We have quadratic models, which is a fancy word for saying story problems with quadratics, okay? Because we're going to find an equation that models our data. Does that make sense? We're going to find an equation that models our data, okay? So, again, what we did, we'll do a scatter plot of this real quickly. I'll probably go by 2, 4, 6, 8, 10, 12, maybe not. Because 31 isn't going to fit. Maybe I'll go by 5s. I'll go by 5s. 5, 10, 15, there's 20, 25, 30. Okay, that'll work. 5, 10, 15, 20, 25, that'll work. And then I like the squishy. You guys ever seen the squishy? Ever seen me do the squishy? Yeah. I like the squishy, and so we'll start with 100. Let's see, 100, 110, 20, 30, 40, 50. Yeah, I'll go by 10s. 110, 120, 130, 140, 150. 110. Okay, and then we'll just do our scatter plot, right? I'll go 12, approximately again 152. Doesn't have to be perfect. 22 and about 105. Doesn't have to be perfect. 30 and about 165. Okay, there you go. Okay, does it appear quadratic? Yeah, I think a parabola, we might be able to fit a parabola in it. Right? Maybe. I'd say yes. Yes, it appears to be quadratic. Yes. And I like, yeah, well, it probably wouldn't be a sign because that's going to keep going up, right? I mean, the faster the bird has to go, that's going to keep going up, right? It wouldn't come back down with higher speeds. Yeah. Yeah. Okay, so then here's what we did. We took our 3 points, right? Right? And we needed a quadratic model, so we used ax squared plus bx plus c equals y. And we created 3 equations, right? And the 3 equations we created, equation 1, we created 144a plus 12b plus a 1c equals 152 by plugging 12 in for x and 152 in for y, right? We created an equation 2 by plugging 22 in for x and 105 in for y, and we wound up with 484a plus a 22b plus a 1c equals a 105. And we created a equation 3, 900a plus 30b plus a 1c equals 165. We saved ourselves the headache of solving this the hard way, right? By elimination method. We could do it by elimination method, but we realized that what we have is matrices. We got a matrix A, which is our 144, our 12, and our 1. 484, 22, and 1. 900, 30, and 1, right? Isn't it nice that we kind of know what we're doing? We did the work 15 minutes ago to set ourselves up now. And we created a matrix B, 152. That's a bad looking 2. It's like Brittany's 3, huh? 105 and 165. There you go. We put these into our calculator. We found our matrix button. We edited A. We made sure it was a 3 by 3 matrix. We put our numbers in, right? Okay. We made matrix B, which is a 3 by 1, and we put in the numbers. To solve it like an equation, we did matrix A inverse times matrix B. So I went back to matrix, and at this point I will not use edit because I've already made it. So I just want A. This A is the A that I made. Enter. I need the inverse button, which is the x to the negative 1, which is that button right there. Times, you have to use a time symbol. Matrices are finicky. Times, I need matrix B. So go back into matrices. I go to B. I don't want to edit